So today's going to be really interesting, um, but it's going to be a little bit less interesting than last week, because last week we actually programmed something. So we programmed this very basic ransomware that all it does is it encrypts. It can generate a key, and then it can encrypt a directory recursively. So starting from a particular path, it can encrypt all files inside of it recursively with that key, and then we're also able to decrypt it. That's basically what we did last stream, and I said that in the future we're gonna start actually creating um, an actual key that can be used with a good encryption algorithm. But first we need to get into encryption algorithms, how it works, all of that stuff. But before that, I wrote a little list of stuff that we still hadn't covered, that we kind of used here in a way, and I wanted to cover that too. We have got bot on Twitch with your name. Oh, I do? Oh yeah, I do. That is, it's also Streamlabs, but using my account instead of Streamlabs account. Anyway, so um, before we can proceed with evolving with this ransomware, we're going to deal with a couple of things. We need to understand basic I/O, and we kind of did that with input function, but we're going to delve in a little bit deeper with what you can do with basic I/O and how you can read from files and write from files. We're going to talk a bit about string formatting, number bases, and virtual environments. Because this is kind of like, it's not a lot, but it is quite a bit of information, and it's not very connected to each other. I decided to kind of split it. So we'll cover it today anyway, but as soon as I'm done with basic I/O, I will just stop the stream and start it right again, and do the same thing as we go along, because when this goes into YouTube, it will be as separate videos, and I think that's kind of slightly better. So we're also going to deal with generators later on and a couple of other things. But this is our plan for today. So let's start with basic I/O. So I'm actually going to create a new directory in our project. It's going to be called input output. Doesn't really matter. And inside of here, I'm going to create a file called I'm just going to create a file called test.py. We're just going to be testing out some stuff. That's why I did that. Okay, PowerShell window. Okay. So let's create a file. And I'm going to make this a bit more obvious by actually going into input output and just stay in here. I'm going to make this a bit more obvious. So I'm going to create a file called test.txt. Actually, let's just rename this. Let's rename this myfile.txt. Right, inside of here, I'm just going to have hello world, programming is awesome, and whatever. And I'm loving it. Okay, let's just do this. So we have 3 lines with text, right? Now, let's say we want to read from this. There are obviously a lot of ways to read from this, but we kind of need to understand what's happening when you're reading from a file. So I'm just going to give you an example of how you can load this. So let's, so to read a file that's on your hard drive, right? Because this file is stored on your hard drive, essentially, and on your disk, and you want to read it. Obviously, Windows has specific APIs you can interact with at the low level to read these files. And Python has functions that wrap around it that make us be able to access those files pretty easily. One such function is called open, right? And if you just go here and you Google up Python open, you'll just see there's a function open. There we go. And you can see a lot of the details about it, the documentation for it. And it tells you that it requires a file mode, or you can pass it a file mode, buffering, encoding, and a bunch of other fields that you can explore. The most important thing is what is really happening when it returns, because we learned that functions return. That's the valuable aspect of functions. So if you have a particular function, whatever it returns, you're going to get it, like a in here is going to be whatever it returns from this function, right? Oops. So what does the open function return? This is what we're going to be getting into. So the first parameter that you pass is the file name. So in this case, it's going to be myfile.txt. And you technically don't need to pass any other parameters, but we're going to be seeing that in a bit. So I'm just going to say myfile equals open with the file name. Now this is relative, right? So it's going to search for the path. So your file, like you could, oops, place your path as C users whatever until you find your name. But because our Python executable is going to be ran from the same directory as our file.txt, you don't really need to provide an absolute path. So a relative path is more than okay. Now let's print my file. Actually, no, let's print type my file, because I want to figure out what it's returning, what kind of thing it's returning. And I might as well print my file and see how this works. Oops, there we go. So if I execute this, okay, there we go. So we're going to have a type, which is going to be an IO text IO wrapper. Perfect. And if we just print it, it's going to print this, which is the same thing, except it specifies a couple more things about it. So how can we make sense of this? So it kind of is useful to understand what objects are, and I'm going to go in a lot more detail into what objects are later when we talk about object-oriented programming, right? Or the object-oriented concepts of Python. But for now, I am going to give you a little teaser of what objects are and why they're useful, because it's important to understand these kinds of concepts. You don't need to know what objects are to understand how to use this, but it's just, it makes it a lot, it makes it less mysterious when you're using this, right? So, but before we go into it, let me just explain you how to use this. So this object allows us to read and write to it, and all sorts of things. And as you can see, it has a name, so that this is the file name, and it has a mode, which is R, and an encoding. And if you go into the website, so just read the documentation, it tells you about the file mode, and it tells you what modes you can have, and it tells you about the optional encoding. So the encoding is optional; it's going to default. So it's going to be whatever encoding happens to be the default in your case. It could be UTF-8. It could be CPU1252. And the modes are going to also, and I touched on this last week, but we're going to delve a bit deeper. So the modes obviously are very important because they're what define whether you are reading or writing to the file, or appending, or all sorts of things. So the basic modes are R and W, because you're either reading a file or you're writing to a file. You can also have X for exclusive creation, which basically it creates the file only if the file does not exist, otherwise it doesn't. You have A for appending to a file that already exists. You have B, which is in binary mode, text mode, etc. Okay, so what does this mean? So after the file name here, you can input a particular mode, and you can specify it with mode equals, but you don't need to because positional arguments work. So mode R. Mode R happens to be the default, which is why you don't need to specify it when you're reading from a file. So when we execute this, it's still the same thing, right? Now, if you change this to W, by the way, I notice that this has words in it. Okay. Now, if I change it to W, and I'm actually going to copy this in case. Now, you see the mode changed here to W, right? But the file just disappeared. All contents disappeared. Why? Because obviously if you come over here and read again, W is open for writing, truncating the file first. So it basically erases everything that's in the file and opens it for being written. I'm going to do this again, and of course you can also append to it, open it in the appending mode. Now we're not doing anything to the file quite yet. I noticed that it hasn't actually disappeared. We're not doing anything. We're just specifying a handler. So this is basically a handler for the file. So it's an object that is going to handle operations for us related to the file. So we can tell the handler, hey, we want to write this to the file, or we want to read from it, or we want to, I don't know, append to it. So how do we read from it? Well, this handler that is returned when you use the open, let's just use with the R mode for reading, has an option has a method, so you can call it handler.read. Okay, and that's it. And if we print this, and again, this is going to execute a function, and if we print this, it's going to give us, obviously, the contents of that file. Hello world, programming is awesome and I'm loving it. Great. Nothing happens to the file, opening it in reading mode. Perfect. Now, it's important to understand as well, if we open this in appending mode, you'll get an error while trying to read it, because it's this handler is not prepared to read it, it's prepared to append stuff into it. Alright, so you gotta make sure that you're using the right modes. Okay. So this is how you read from a file. Now, how do you write to a file? Well, write. And you can do whatever you want here. So handler.write, whatever you want. Now, you can write hello, for example. Now, again, if we run this, it's going to give us an error because we didn't open it in write mode. But again, if we open it in write mode, it will erase everything. So let's just do A mode. And in this case, it returned a 5, and we're going to understand why later. But if you go to my file, it now has a hello afterwards, right? And if you keep doing this, it has a hello. And I can tell you now, hello has 5 characters. This is where this 5 is coming from, and I'll show you in a bit why. Okay, so we learned how to read and to write, but these are not the only ways we can read it, by the way. There are other ways in which we can read files, because sometimes it's useful for us to read a file line by line and put each line into a list. Now, what can we do? Well, obviously, we can say that our file content equals handler.read, right? We just read everything, and it's a string. And again, if we print the file content, and I'm doing something wrong here. I've been doing something wrong here, but I'll show you in a minute why it's wrong. Oh, oops. So again, we have the file content, and of course this is a string, right? It returns a string, and we can use methods of strings to split it into a list. So we can split, for example, on new line, and right now it will give us a list of lines. So we have 3 lines, and we have 1, 2, and 3 outputs in the list. So we have hello world, programming is awesome, loving it, right? But here's the thing. What if you have, and let's just say, this is a really stupid example, right? But let's just say we have, I don't know, this, like 7,000, let's say we have like 7 million lines, but I'm not going to put them all here, just to prove the point. Let's say that we, oh, and by the way, I'll do that in a bit, don't worry. Let's say that we do the same thing, right? We're doing the same thing. But now our file is significantly larger, right? So let's run it. It's going to run pretty easily. But you see where I'm going with this. If this file was incredibly huge, there would be problems using this, right? Because obviously what this does is it just gets all of the output, all of the content of the file. but sometimes we want to get segmented content of the file, right? The file is incredibly huge. It's a data science file or whatever. You might run into problems storing every single part of this text into a variable. You might just want to read it line by line. Well, how do you do this? Well, you can of course interact with the file handler in a different way, where you just keep reading Vaplife, yeah, you know it, where you just keep reading individual characters until you find a new line, and then you just keep getting that content. But a far better way to do it is to invoke this handler again, right? But instead of asking a read, so let's just print the file content, we can ask a read line. And what is this going to do? Well, this is going to read the line. But here's the thing. What if we want to read many lines in a row? And this is actually really interesting. I'm going to open the interactive shell because it's going to be easier to demonstrate this. So let's say f equals open my file.txt for reading. It's only for reading, so it doesn't matter that I didn't close it, that I'm not going to close it soon. But so let's do a read line. This is what comes up, right? Because it's the first line. And notice that the read line, of course, the delimiter of a line is going to be the new line character. So that's how it breaks into the different lines. If you do this again, though, you're going to get the second line. And if you do this again, you get the third line and fourth line, etc. And this is because there's... and this is really interesting. And this is because there is a... let's call it a counter or an index. We're going to go deeper into this when we actually deal with these things in a low level in C. But let's just call this kind of like a buffer index, where you're incrementing it by 1, or incrementing it every time that you are adding a character. So you add a character, you increment it by 1. So in practice, what happens? In practice, what happens is, it's the same thing as if you had, say, a string, hello, right? And every time you add, and now the representation of the string is just hello, right? Or actually, let's have an empty string. So an empty string. But and you always read this string at a index. So index equals 0, and you're always going to read this string as a index, right? Now, obviously, when we add a character, a index is that character. But remember, we always, every time we add another value, so let's say we add another character, b, we have to increment the index by 1. So in this case, that will be b. And what happens when you are reading the line is basically the same thing. So you read the first line and you increment that, that index. So whenever you read this the second time, you're always going to read the second line, and so on. And this also works for read, by the way. So if you have, again, I don't remember if f was, I'll just open it again. It doesn't matter that much right now. And this might seem a bit confusing, but you'll see where I'm going this with a second. So when you do f.read, it's going to read the entire thing, right? And it's going to update that buffer. It's going to update that index. For basically every you can think, oh damn it, you can think of it as every character that it reads, it just adds 1 to that index. So at the very end, that index is at the very end of the file. So now when you call read again, there's nothing there, because the index is at the end of the file, and it's going to try to read from this index, which has nothing, right? So it's the same concept. Now, we can, of course, position this index wherever we want, and this is by calling another function called seek. So you call seek on your handler, and you can place it on the position you want. So if you do 0, it will be the first position, and it's going to return it again. And now if we do read, it's going to read the whole thing again, right? But now if I do a seek, damn it. Now if I do a seek on, let's say, let's make this a bit smaller so we can actually see what's going on here. I shouldn't have made this too big because I wouldn't be able to prove my point without it being similar to C. Yeah, exactly. But in Python, it's actually quite problematic to think about things in the same way as you think about things in C, because a lot of the times you're dealing with things that will actually interact with the the API in a way, but it will have a level of abstraction that is doing a lot of things in the background that you sometimes are not really aware of, and that might bite you in the ass as well, because you might be expecting something to be treated as in a specific way as it is in C, because the concept is similar, and then you notice that, oh wait, Python is doing this to it, and it's not matching up, and it can be tiny things, but it can break your code. Oh shit, mosquito. Okay, so again, as I was saying, oh, is there not an F now because I did the thing? Okay, fine. So let's open the file again, my file.txt. And a lot of people are already cringing at how I'm opening a lot of these things and I'm not closing them, but we'll get to that point. So again, we're going to read this, right? And this is what it is. It's perfect. Of course, the new line here is represented as the dash n, as the \n, because that's the new character representation, the new line representation. Now, if I do this again, it's empty because the index is right there, right? But now we can also seek it to be 0 again, and now we can read from 0. But you can also do this from 50, right? And now if you read, notice it started with the ng, right? So it started like here, because this is index 50, right? And you can do all sorts of stuff. Oops, that's not what I meant. It's not what I meant either, but you get the idea. So this is what you can do. And this is important to know. And the reason why this is really important to free, because a lot of people don't get this in the beginning. A lot of people don't understand this because a lot of people don't actually get that information. When you look online for how to open and read from files, what they say is, you do an open, or you do the with statement, we're going to look into that in a bit, and then you do read, or you do read lines, or with a for loop to append to the data, whatever, and that's it, and that's how you read from files. And people will try this, and they'll be, oh yeah, I can read from files, and then they will use that in the code, and then they'll want to read from the file again because maybe they changed, I don't know, they did something, they want to read from the file again, and oops, it doesn't work. Like, the file is empty, but the file has stuff. Or you wrote to the file before you read it, and when you're reading to the file, you had the handler open, and this is the problem of having handlers open. So if you have this handler open right here, right, and you have, let's call this read handler, write handler, and this is going to be in write mode, and so actually let's put this in append mode, right? So write handler dot write test, right? Just do that, and then we're going to print read handler dot read, and we're going to do this twice. We're going to do this here. We're going to do this here, and oh, we're actually also going to do this. Damn it! We're going to do this here. Dot seek 0, and let's try this out and see what the output brings us. Because yeah, so oh, I should have done this. Okay, so okay, so right now you wrote. So what is happening here? And this is to prove to show the point that I was saying before, but it's easier if you see it. So what are we doing? We're printing the read. We just created two handlers, read and write, because again, each handler has a mode, so you can either be reading or writing to it. And this is an append, right? But it's still a write operation. You still use the write. So we have two handlers, one to read the file, one to write to the file. Now, first I just print this handler dot read with the parentheses, so we're just reading from the file. Then I'm just printing the thing saying writing now, just to separate this, so here, and then we write to it. We use the write handler to write test at the very end. Then we use the read handler to do the seek again to 0, because remember how we had to make sure the index was at the very beginning, so we can actually read the file from the beginning, and then we read again. And as expected, we get the whole output, and we get the writing now, and we get our output, right? Now here's the thing. Okay, I'm gonna do this so you can actually see that it doesn't have the thing. This is why, like, opening handlers and using them afterwards, expecting it to go fetch it, is actually really, really bad. Because if you notice, we added our test, right? It's here, the file has it, but nowhere in here does the test come up. Even after we wrote it, even after we used the seek to get back to the beginning, right? It's not here. Why? Well, oops, I messed up. Oh, you actually can't have this. Never mind. My bad. I thought that you could, but you can't. Never mind. I was wrong. Interesting. So I guess you can't do it. It makes sense, and this is one key difference as well from what Polly was saying. So and the reason that this happens is because when you call the read handler, right, it's going to return an object that is prepared to read from this particular file, and it's going to load a buffer. And when you're reading from it, you're reading from the buffer. Okay? And when you say read line, for example, or read lines, you're always reading from that buffer. And this is done for a purpose, and I'll show you in a bit. But that means that that buffer is static, right? When you're writing to it, you're writing to the file itself. But this content of the file is not in the buffer that was loaded beforehand. So when you read it, oh, Shane, what's up? So when you read it, you're going to actually be reading from the original buffer, so you're not going to have this thing written on it. Now, another thing about this, so these are just like particular things to be careful of. I don't expect you to understand everything about it right now, but just things to keep in mind of sometimes. Even if you forget about it, that's fun as well. And of course, this seek option is also very important to keep in mind because, again, if you read it twice, reading once, I'm just going to print reading once, and then I'm going to print reading twice, and you're going to see, you know what, I'm just going to do this as well so we can see a new line. So reading once, new line, sorry, my bad, I meant this, but that too, whatever. So reading once, so this is reading once, and then reading twice, and then of course it's empty again, right? And that's because of the seek. Now if you do a read handler dot seek 0, of course this again is going to read the whole thing again. Right, so two aspects to keep in mind. Now, what was the buffering thing that I was talking about before? Well, so think about this, right? Let's say you have a file, right? And we actually don't need this. So you have a file, and this file has a lot of content. It's a really huge file, or it doesn't have to be that huge, but it's a big file. And you want to read from that file, but you want to read from that file. Not everything. You don't need everything from that file. You just need particular segments of that file, or you need just the first line, or you maybe just need the first line of that file sometimes, or some particular lines of that file, whatever it is. Think about that. Nowadays it's not that important anymore, but it used to be very important. Think about this. You have spinning hard drives, right? And a lot of the times you also have old hard drives. And of course, you also want to make sure that you're not working the hard drives all the time, because if you're always accessing the hard drive, of course there are limited number of reads and writes, right? So you're going to tear it. You're going to make it. It's going to break faster, right? I'm missing the correct word, but it's going to break faster. So instead of always just getting, say, accessing the disk for a particular part of the file, and then accessing the disk for another file, for another particular part of the file, then accessing the disk again, then accessing the disk again and again and again, every time you need that file, this can become pretty bad for that purpose, but it can also be pretty inefficient. It can be slower, especially with slow hard drives. So what's the idea behind the buffering part? So you load a bunch of data into it, not the whole file necessarily, right? You can do that if you want to, but you don't have to. You load a lot of content from that file into your object, right? So you create a buffer and you put a bunch of that content into that buffer. Now, when you need to read from it, you just read from that buffer, right? You don't need to read from the file. If you need to read it more than once, or if you need to read multiple parts of it at different points in time, you don't need to go to the file. You have the buffer, right? And the buffer is in memory, so you're not using the hard drive. And that's kind of a part of the concept of it. And so this is buffered. So when you have the buffering option here, you can't apparently put it to 0, but you can put it to 1, I guess, right? Can you? This is interesting. There's a lot of things happening in here that, oops. So let's just print this again, right? And I'm unsure, how long did we make this file? I don't know. But there we go. Okay, so we can make a buffering of 1, for example, right? Which is essentially the same thing as saying that, like, my buffer is only 1, so if I need more than that, I will have to go to the disk and get more anyway. So you're basically doing the same thing. When you don't specify this, this will be a default value that will usually be very it will usually be very helpful, which is why, you know, it's the default value, and people don't usually mess with that if they don't need to. So yeah, that's a little part about the buffering. Now notice how we are not specifying an encoding, right? We could specify encoding UTF-8. I didn't actually do anything, but we could specify an encoding we want. By default, it should it has a default encoding based on your system, based on your settings. But you can specify your encoding if you want to. This can be useful, for example, if you want to, if you're reading a file that have things that are in a very particular encoding that is not the default one, right? So this can be useful as well. Now so this is how you read and write from files. So we just learned how to read and how to write from files. There's a very important aspect I didn't touch yet. So again, let's go back to the read handler. So this is what we've opened a connection to this file, right? This is what the handler does. The handler just opened a connection to this file in a way, and it's a read connection, so it's going to be reading from it. Now, when you look at when we go into networking and we're looking into sockets and all that stuff, we're also going to see stuff like this, where when you open something, like, it tends to keep open, right, until you close it, and you kind of want to close it so that you don't hog resources with having it open, and also so that you kind of clean yourself up, because if this stays open, it can be accessed at any other point in time in your code before it's closed, and it's just good practice to always close it, especially if you plan to write stuff to it and then have other processes come in and open it, and it's really important that you close it when you don't need it anymore. How do you do this? Well, you call the read handler. So we learned about read like the handler.read line. Read lines. By the way, read lines is the same thing as read line, but reads everything into lines, right? We learned about write, but to close, you just do close, right? And then it's closed. And then if you try to read from it, it will give you an error because it's already closed. IO operation on a closed file, right? Gives you an error. So we covered this last time before, I think. Now, something we covered last time as well. If you have a lot of IO operations with files, you don't really want to always like explicitly have an open and then a close and then do whatever you want in between. It's really easy to forget to close it, and it's just bulky. So what you can do is you can use a with statement. So you can use with open and then the file name. So let's say my file txt as mode r, oops, r, then colon, kind of like an if statement, or right, you just put the colon there and then everything inside of it is like indentated. Now of course we don't need this anymore, and we can say as read handler. What this does is it's very English driven, like it's pretty easy to understand in an English way as well. So basically it takes this open, it opens the connection to the file, right, and treats it as read handler. So this is a variable right now. Actually, wow, didn't know that. So yeah, as you can see, it's a variable read handler, and it's a text IO wrapper because this is what this will be returning, right? So the read handler, this is basically the same thing as saying read handler equals this. But with the with statement, what you can do is you can do all sorts of operations here, and as soon as this is ended and you continue with your normal code, this will be closed. So you don't have to close it yourself. So this is why this is really useful. With the with open, this is immediately closed. So with open this, you can just say print read handler dot read. It's exactly the same thing, right? It's the exact same thing, but you don't need to close it because it's already closed as soon as you get here. And you can see this because if you try to, let me just copy this, if you try to print it again, oops, it will not work because it's a closed file already. Right? And there are other ways to do this as well. You can do, for example, I'll tell you this in a minute. It's just best to keep things simple for now. So this is the preferred way to read a file, and similarly to write a file with W or with whatever mode you want. Right? So this is the preferred way to do it. By the way, this is not needed. This is not needed. It's just, it's stupid that it was there. It was probably like the auto modulars, whatever. So as you can see, pretty easy, right? Is there any questions about this? Because I noticed that sometimes my explanation might have been a bit confusing. So do you guys have any questions about this particularly? About any aspect of what I've said so far? Just going to look at chat. Okay, there's no chat. No questions, I guess? Okay, fair enough. We also only have one viewer, I think, but that's still fine. So it's very unlikely that there will be questions with only one person, who's probably me as well. Is it me? No, I'm not watching, so it's not me. Okay, so no questions. That's great. Let's continue, I guess. So right now, how long has this been? Not too bad. Okay, so these are the final touches of reading files. So we learned how to read and write to files and append all sorts of stuff. But this is not all you can do. So you could also mimic the same behavior with, so you can have buffer. So it's basically a buffered IO operation. You can do the same thing with in-memory buffers, right? So what you can do, for example, is you can import a standard library. You don't need to install anything. So import IO, and in here we're going to say that we have a handler. So handler. So again, it's still a handler. IO.string IO. You could look into this in the documentation. This is basically going to give us, so if we print a type handler, right here, we actually don't need this, so let's print this, and it's an IO string IO, perfect. If we just print the handler, we should have some information. Yeah, it's a particular object that has located that address. Okay, so what we can do with this is, just like a file handler, we can do a handler.write hello, and we can do a handler.read to see what's in there. Now notice as we do this, nothing is in there. Like, sorry, I didn't print this, but if I printed this, there would be nothing there. Why? Well, again, because of the same thing I said before with the seek. Every time you write or read from it, it's going to update the index of that operation. So if you put the seek to 0 again, then it starts from the 0. And this is also when you do the write, and I showed you that you get some numbers when you do the write. So if you print this, by the way, so this returns a number. If you print this, you'll notice that it's 5. It's 5 because hello has 5 characters, and now the buffer stands at 5. And after 5 characters, there's nothing, but that's why this read gives us nothing. If I put hello with 2 O's, this would return 6, right? Now the buffer would be at 6. And of course, we can make the buffer with seek. We can say it's going to be at 2 instead of 0, and then it's going to start from 2, which of course, right there. So 0, 1, 2, there we go. Easy stuff. And yeah, and this is how we do this. Now similarly, and it's exactly the same thing as for what we said before, to open a file, again, we can use the with open, so my file. And you don't have to put a handler here, you can put as F, it doesn't matter. I call it handler because it makes it easier for me to understand what it's doing. It's handling that file. Notice that now I put a B instead of just the R. And you can do this to specify that you're opening it in binary mode. So RB for read binary, WB for write binary, AB, etc. And what does this do? Well, it reads this as bytes. So instead of returning, so if you now do handler.read, and of course if we print this, right? So let's print this. Oops, print this. Okay. It's going to print a byte. Actually, we should probably print type so that we can clearly see that this is bytes. It's a bytes. There's nothing in here. It's a bytes, right? Now, if we just print that instead of the class, you're going to have the same input, but with the B prefix there, saying it's bytes. And that's it, right? And this is really useful because, well, first of all, it's going to be more efficient in many ways to read bytes. And it's, of course, really useful when you're doing encryption and you're reading from non-text input. So if it's not a string that you're reading from, well, if it's not a text string, if it's, for example, a byte string or like a byte array, or if you're reading from an executable file or a JPEG or whatever, it's going to have a lot of bytes in there that you're not going to easily be able to manipulate if you're doing this in text mode, because that is going to be, of course, using an encoding to translate those bytes into particular text, and you don't want to translate it because you want to deal with those particular bytes. So this is why byte mode is really useful. This is how you read with bytes. And similarly, you can do the same thing as we did before as well with the string IO. I should have just commented out. Again, you can do the same thing, like the exact same code, but instead of saying string IO, you can do bytes IO. It's the same thing, but with bytes. But the only thing you have to be careful with, of course, we cannot write a string, we have to write a byte string. And if we print this out, it'll be the same thing. So we add 6, then we start at 2, it's the same thing, right? Okay, great. So this is input and output. Pretty easy stuff. Well, file input and file output. Yeah, that's pretty much it. What else did we have to go over. I think this is input and output done. Let me just make sure of it. So let's, actually I can just do that. So basic IO, string formatting basis. Okay, so we're done with basic IO, which means I'm going to just end the stream and